Okay, lesson 57 is about the ideal gas laws. The general ideal gas law says that P1 V1 over T1 is equal to P2 V2 over T2, where P is the pressure, V is the volume, and T is the temperature of an ideal gas. The ones that have the little ones next to them are the initial pressure, volume, and temperature. The ones with the little twos next to them are the final pressure, volume, and temperature. Units for pressure are newtons per square meter, or atmospheres, millimeters of mercury, torrs, and pounds per cubic inch. Volume, you can have liters, milliliters, cubic centimeters. Temperature, we're going to use kelvins all the time. So if we omit one of the variables from that general ideal gas law, we can get three other gas laws that just involve pressure and temperature, volume and temperature, or pressure and volume. So we're going to take a look at a couple of examples using the ideal gas law. All right, 4 liters of an ideal gas at a temperature of 800 kelvins had a pressure of 100 newtons per square meter. If the volume were increased to 10 liters and the temperature reduced to 600 kelvins, what would be the pressure? So we want to look at the problem and fill in all of these little values, P1, V1, T1, P sub 2, V sub 2, T sub 2. So we'll go ahead and put parentheses for everything. So we've got P1 here, V1 here, T sub 1 here, P2, V2, and T2. So we're just going to fill in all those values from the problem. So we have 4 liters of an ideal gas. That is volume. So we're going to fill that volume in right here. So 4. So that's the initial volume. All right, now it says 4 liters of an ideal gas at a temperature of 800 kelvins. So the temperature is 800 kelvins to start out with. So we'll put that here where T1 goes. And now we're looking at the pressure of 100 newtons. All right, now we're going to fill in P2, V2, T2. If the volume were increased to 10 liters, so now the volume V2 is 10 liters, so that goes where V2 is. The temperature has been reduced to 600 kelvins. We're going to put the temperature where it goes down on the bottom. And then we're looking at the final pressure is what we want to find. What would the pressure be? So final pressure is what we do not know. So P sub 2 is what we're going to solve for. Now we are just going to cross multiply and solve. So we'll have 100 times 4 times 600. I'm multiplying here equals, now I'm going to multiply here, 800 times P sub 2 times 10. And now to solve for P sub 2, I am just going to divide both sides by 800 times 10. And these will cancel. And over on the left side, I can cancel some factors of 10, get rid of these 2 zeros here and these 2 zeros here. I can get rid of 1 0 here. So now I have 4 times 60 is 240, and that is going to be over 8, which is going to be 30 newtons per square meter. Okay, here's another example. The initial pressure of a quantity of an ideal gas was 400 newtons per square meter, and the initial temperature was 1200 kelvins. The volume was held constant. What was the pressure if the temperature was decreased to 900 kelvins? Okay, so we know our ideal gas law is just P1 V1 over T1 equals P2 V2 over T2, but this one says that the volume is going to be held constant. So we don't really need to include the volume in our formula because it's not going to change and it won't matter. So we'll just have P1 over T1 is equal to P sub 2 over T sub 2. So now let's just fill in the information they gave us. The initial pressure of a quantity of an ideal gas is 400 newtons. So that's P sub 1. And the initial temperature was 1200 kelvins. So that's T sub 1. The volume is still constant. We already saw that. What was the pressure? So pressure is what we don't know. If the temperature was decreased to 900 kelvins. So now we have a ratio, we have a proportion, and we can cross multiply. So 400 times 900 is equal to 1200 times P sub 2. And now we can divide both sides by 1200 to get P sub 2 by itself. 1200 cancels. We can cancel some zeros here. Cancel 2 on top and 2 on the bottom. So we've got a 12 on the bottom and a 4 on the top, so we can cancel the 4, and we'll have a 3 left over. We've got a 3 on the bottom and a 9 on the top, so we can cancel the 3, and we'll have a 3 left over there. So all we have left is 300, and that is going to be, so P sub 2 is going to equal 300 newtons per square meter. Example 57.3, the temperature of a quantity of ideal gas was held constant in the experiments. So the temperature is going to be held constant this time. So we're going to get rid of temperature. P1 V1 over T1 is equal to P2 V2 over T2. So this time the temperature is going to be held constant. So that means we can just forget about it because it's not going to change. So our formula this time will just be P sub 1 V sub 1 equals P sub 2 V sub 2. So the original pressure was 7 atmospheres. So that's P sub 1. The original volume was 42 liters, so that's V sub 1. If the volume was reduced to 10 liters, what was the final pressure? So the final pressure is what we do not know, and the volume was reduced to 10. So this is what we have to solve for P sub 2. We can divide both sides by 10. 10 cancels out. Nothing cancels out very easily here, so 7 times 42 is going to be 294, and that's going to be over 10, so that is going to be 29.4 atmospheres for the pressure this time is the units they're using. Lesson 58, we're going to do some more on completing the square. This time we're going to do completing the square on a quadratic equation where the leading coefficient is not 1. If you watched the video I sent for you to have a review of completing the square, you remember that in all the problems we've done so far with completing the square, the lead coefficient is 1. So what I mean by that is in a quadratic equation, the coefficient of the x squared term is called the lead coefficient or the leading coefficient. And in order to complete the square to solve a quadratic equation, it is necessary that the leading coefficient have a value of 1. If the lead coefficient is not 1, we must divide every term on both sides of the equation by the lead coefficient before we can complete the square. So that's what we're going to have to do on this next problem. So on this equation, we have 4x squared plus 3x minus 3 equals 0, and we want to solve this for x. Find out what values of x will make this equation a true statement. That's what it means by solve. It means find the values of x that work in this equation. There should be 2 of them because this is a quadratic equation, meaning that the power on x is 2. So we can see that the lead coefficient is not 1, it is 4. And so what we have to do here is divide every single thing in this equation by 4. So we're going to divide this by 4, divide this by 4, this by 4, and this by 4. So what will we end up with? Well, the first term will just be x squared. Second term will be 3/4 x. The last term will be 3/4, and we'll have a 0 on the right side. All right, so now we're just going to complete the square as we have learned before. It's the same process. So we're going to move the constant back to the right side of the equation, and we're going to leave a blank right here. So we're going to add 3/4 to both sides to get that out of the way. And we're going to put plus blank on both sides. Now, the thing that you put in the blank is going to be half the x coefficient squared. So the x coefficient is 3/4. So we're going to take 3/4. We're going to take half of it, and then we're going to square that. So that is 3/8 squared, which is 9/64. So that is what we're going to add to both sides. Now we will write the left side of the equation as a perfect square. So something squared, two things, x, and then what goes here? Well, it is going to be half the x coefficient. So it's going to be 3/4 times 1/2, which is 3/8. So the left side of this equation is equal to x plus 3/8 quantity squared. That's why we chose 9/64 to go in the blank, because that makes this whole left side of the equation equal to x plus 3/8 quantity squared. The right side of the equation, we're going to need to get a common denominator so that we can add these. The common denominator is going to be 64. To get that, you will have to multiply this first fraction by 16/16. So that is going to give me 48/64 plus 9/64. So if I write this again, I'm going to have x plus 3/8 quantity squared is equal to 57/64. Now I can solve for x by taking the square root on both sides of the equation. On the left side, I will take the square root. On the right side, I will put plus or minus and take the square root. When you take the square root of a square, that's going to cancel the square out, so you're just left with x plus 3/8 on the left side. On the right side, you're going to have plus or minus the square root of 57 over the square root of 64, which is 8. Now to solve for x, we're just going to subtract 3/8 on both sides. So we will get x equals negative 3/8 plus or minus the square root of 57/8. That would be your final answer. Those are the two solutions for x, negative 3/8 plus the square root of 57/8 and negative 3/8 minus the square root of 57/8 are the two solutions to this equation. Now let's solve this quadratic by completing the square. Again, our leading coefficient is not 1, it is 5. So we're going to divide everything here by 5. This is going to give us x squared minus 1/5 x minus 2/5 equals 0. Now we are going to move the 2/5 back to the other side of the equation and leave a blank because we're going to fill that blank in. We're going to move the 2/5 over. It's going to become positive 2/5, and we're going to put plus blank. All right, what goes in the blank is going to be half the x coefficient squared, so 1/5. Take 1/2 of it and then square it, which is 1/10 squared, which is 1/100th. So we're going to add 1/100th to both sides. And now we will write the left side of the equation as a perfect square binomial. What is going to go in there is going to be x minus, because this is a minus sign here, half the x coefficient. So half of the x coefficient is going to equal 1/10. So 1/10, and that is the left side of the equation. This whole left side can be written as a perfect square, x minus 1/10 quantity squared. On the right side, we have to get a common denominator, and that is going to be 100. So we're going to multiply the first fraction by 20 over 20 to get 40 over 100 plus 1 over 100. So we're going to have x minus 1/10 quantity squared is equal to 41 over 100. And now we're going to take the square root on both sides of the equation. But we're going to put a plus or minus on the right side. We only put the plus or minus when we take the square root on both sides of an equation. Some of you have been putting plus or minus when you square both sides of an equation. That is not a true statement. So you need to put plus or minus only when you take the square root on both sides of an equation. So on the left side, the square root cancels out the square, and we end up with x minus 1/10. On the right side, we have plus or minus the square root of 41 over the square root of 100, which is 10. Now we're going to add 1/10 to both sides to get x by itself. So we will have x equals 1/10 plus or minus the square root of 41 over 10. And that is your final answer. Those are the two solutions to this equation. 1/10 plus the square root of 41 over 10 and 1/10 minus the square root of 41 over 10. Okay, lesson 59, simultaneous equations with fractions and decimals. We have seen before that when you're working with an equation involving fractions or decimals, it can be helpful to multiply both sides of the equation by a number which will cause all of the fractions or decimals to cancel out. And that's what we're going to do here. We have two equations. One involves fractions and one involves decimals. So we'll multiply each of these equations by the appropriate number to make those decimals and those fractions cancel out. So I'm going to look at the first equation. It has denominators 2, 5, and 5. If I multiply that whole equation through by the least common multiple of 2 and 5, all those denominators will cancel. So I'm going to multiply that first equation, all the terms in the first equation, by 10, which is the least common multiple of 2 and 5. So 10 times the first term, which is x over 2, 10 times the second term, which is 3y over 5, 10 times the last term, which is negative 2/5. For the second equation, I can see that I have two decimal places in this one, and only one decimal place here. And so since the 2 on the ends are in the hundredths place, I need to multiply all of these terms by 100 in order to move the decimal places far enough to the right so that I have whole numbers. So I'm going to multiply that whole equation by 100. So we have 100 times 0.06x minus 100 times 0.2y equals 100 times 1.04. So let's go ahead and do the multiplication. In this first term in the first equation, the 10 cancels with the 2, and I end up with just 5, so 5x. In the second term, the 10 cancels with the 5, and I'll have a 2, so 2 times 3y is 6y. And then in the term on the right side of the equation, the 10 cancels with the 5, and I'm left with a 2, so that is negative 4. In the second equation, the 100 moves the decimal point 2 spaces to the right, so I'm going to end up with 6x minus, in the second term, 100 times 0.2y moves the decimal place 2 to the right, so I end up with 20y. And then on the right side of the equation, multiplying by 100 moves this decimal point 2 to the right, and I end up with 104. So these are my new equations. So now I want to solve this by substitution or elimination. It looks like the best thing to do would be to solve this by elimination. To do that, I'm going to multiply the first equation through by 6. And I'm going to multiply the second equation through by -5. This will cause the x's to cancel because I'll have a positive 30x in the first equation and a negative 30x in the second equation. So if I multiply the whole first equation by 6, I'm going to have 30x plus 36y equals -24. If I multiply the whole second equation through by -5, I'm going to have negative 30x plus 100y equals 520. That's negative. So now if I add the two equations together, the x's cancel and I end up with 136y is equal to negative 544. And if you divide both sides by 136, you get -4, so y is equal to -4. Now we need to go back and plug that in to one of the equations to figure out what x is. So I'm going to plug that -4 into this equation right here for y. So if I do that, I'm going to have 5x minus 24 equals -4, which means that 5x is equal to 20, which means that x is equal to 4. So my solution for this system of equations is going to be 4 for x, -4 for y, and this is how you write the solution as a coordinate pair. 4 is your x, -4 is your y, and you have to have parentheses around that and a comma between those two numbers. Okay, now we're going to talk about changing rectangular coordinates to polar coordinates. In the video that I sent you for review, you should have reviewed how to change polar coordinates to rectangular coordinates using sine and cosine. And so now we're going to learn how to go the other way. We're going to learn how to convert rectangular coordinates to polar coordinates. And this time we'll be using tangent to do that. So first of all, it says convert -5, -3 to polar coordinates. And just a reminder, your book might write that as -5r minus 3u, just so you recognize that that means the point -5, -3. So the first thing we're going to do is graph that point. So we're going to go 5 to the left and 3 down. That puts us in the third quadrant, and we're at the point -5, -3. Those are the rectangular coordinates for that point. We want to find the polar coordinates for that point, and the polar coordinates would tell us how far out from the origin you would go to get to that point. That would be the radius or the hypotenuse of the triangle. And then we want to know the angle that you would have to rotate to get to that radius, starting from 0 and going all the way around to that radius. Now we are going to find the angle between the x-axis and that hypotenuse or that radius. And then to get our answer, we're going to have to add 180 to that because we are talking about 0 degrees over here, and we're going to have to go all the way around to there. So we're going to find theta, which is just the angle between the radius and the x-axis. And then when we're done, we'll have to add 180 to that because we're in the third quadrant, and going all the way around to there means I'm going to go 180 because this is 180. And then I'm going to go theta more. And so we have to find out what theta is. And so, as I said, to do that, we're going to use tangent, because if we're looking at theta, we have the opposite side to theta, which is 3. We have the adjacent side to theta, which is 5. And tangent, if you remember, tangent of an angle is equal to opposite over adjacent. So in this case, if we're looking at theta in our drawing, tangent of theta is equal to opposite over adjacent, 3 over 5. Now, to find theta, I can't find the tangent of 3/5 to get theta because that's not what this equation says. The equation says that the tangent of theta is equal to 3/5. So I have the ratio. I don't have the angle. So I can't take the tangent of the angle if I don't know what the angle is. So I'm going to have to use inverse tangent to find the angle. So inverse tangent of 3/5 is going to tell me theta. So you use inverse tangent when you have the ratio, like opposite over adjacent, and you're looking for the angle. So I will get my calculator and I will punch that in. And so the buttons I will push would be these. I would hit 3 divided by 5. Then I'm going to hit equals. Because if I don't hit equals and then I hit inverse tangent, I'm going to be taking the inverse tangent of 5 because my calculator doesn't know that I want to take the inverse tangent of 3 divided by 5 unless I hit the equal sign before I hit inverse tangent. So you're going to hit 3 divided by 5 equals. So I will put second and then tangent. And then that will give you the answer. You shouldn't have to hit equals. And that will tell you what theta is. And that's going to give me that theta is about 31.0 degrees. And as I said before, we don't want to know that angle. We don't want to know this little bitty angle. What we want for our polar coordinates is the angle that starts as 0 here and goes all the way around to that radius, that h, that goes out to the point. So we need to add 180 to that 31 to get the actual angle for our answer. And remember in your book, they put this little bracket like this, and inside the bracket will be the angle. So inside there, we've got 31.0 plus 180. And so that is going to be 211 degrees. And now we need to find h, or really what we should be calling it is r, the radius. So to find that, we could use another trig function, but the easiest way in this case is to use the Pythagorean theorem. So we will say 3 squared plus 5 squared is equal to h squared. So that means that 9 plus 25 is equal to h squared. So 34 is equal to h squared. If you take the square root on both sides, h is going to be the square root of 34. So that is what will go right here. And that would be your answer. Those are the polar coordinates for that point, -5, -3.